And hang on. I've got something playing in the background. I didn't realize I had turned my volume down and didn't realize that I still had that playing. All right, so I'm going to go ahead and turn my video on since I'm on the school's internet today, and I think I've got a better bandwidth here than I do at my house. All right, hi. Okay, so this is the lecture for 1.9. Welcome everybody. Thanks Dave for making it into the classroom today. First thing that you encounter in 1.9 is the distance formula. So I'm going to take a moment today and tell you where the distance formula comes from, because if you can understand how the distance formula was derived here, you don't ever have to memorize it. You can derive it yourself if you understand it. So you don't have, well, I mean, it's nice to have it memorized, but there are situations like midterm where you're not going to have a formula sheet and you may forget. And if you can remember this, then you can get to the distance formula. So the distance formula gives us a way to find the distance between 2 points. So say we're talking about this general point here and here. When we're finding the distance between those 2 points, what we're actually doing is finding the length of the line segment. So the first thing that we do, it does not matter where your line segment lives in the XY plane. You can always form a right triangle with that line segment as the hypotenuse of the right triangle. Now the hypotenuse is always the side of the triangle opposite the right angle. So this distance that I'm trying to find, what I basically do is make that the hypotenuse of the right triangle. And how the reason we're wanting to do this is because we have a formula that most of us are very familiar with, and that is the Pythagorean theorem. That talks about the lengths of the sides of a right triangle. So what I basically do is use the Pythagorean theorem in a fancier form to figure out what the length of that hypotenuse is, which in turn is actually the distance between my 2 points. So the first thing that we have to do is find the length of the legs of the right triangle. So this first leg is in the horizontal direction. And anytime you're trying to find the distance between two things, you're actually finding the difference between them. So if I tell you I walked onto campus today with $10 in my pocket and now I have $2, what's the difference between what I had and what I have now? You'd say 8. And you do that by subtracting your second value from your first value to get what's in between. That's the same way that you find that the distance here in the horizontal and the vertical direction. So all that's happened here, the reason it's in absolute value signs is so that if it were to come up negative, that wouldn't be an issue. You know, we can't have a negative distance, so we just take the absolute value of that value there to find that distance. And so all we do is start with one of our horizontal locations and subtract the other horizontal location from it to get that difference between the two of them. That will give you the side length A. So this side length A is actually equal to the absolute value of x sub 2 minus x sub 1. Now the next length that we can find is the vertical side. So this distance right here. And you're basically doing the same exact thing that you did in the horizontal direction, except now you're doing it in the vertical direction. So you're finding the difference vertically between your highest part of your line segment and the lowest part of your line segment. So side B here, or leg B, is actually equal to y sub 2 minus y sub 1. Oops, that's an absolute value sign. So it's the difference between those two things. Now, the Pythagorean theorem says that a squared plus b squared equals c squared. Well, I've got a squared and I've got a and I've got b in regards to my general points x1, y1, x2, y2 that I'm trying to find the distance between. So my length A is that horizontal difference there. So I could substitute in for A x2 minus x1, and then I'm going to square that. Now, I dropped the absolute value signs because squaring it is going to get rid of that. It is going to get rid of that negative. So I don't really have to worry about using the absolute value signs. Welcome, Trina. It's good to have you. We're talking about how the distance formula was derived from the Pythagorean theorem. And then I would add side B in. And side B is my vertical difference, so y2 minus y1 squared. And that equals c squared. Well, I don't know what this c is. That's what I'm trying to figure out. And we actually call it d when we're talking about distance. So all of that's going to equal d squared. So now I just need to solve for d to figure out what the distance is. Well, to get d by itself, since it's squared, I'd need to take the square root of both sides, and that leaves me with d equaling, it should be the positive or negative square root, but since we're talking about a distance, we only worry about the positive. Square root of x2 minus x1 squared plus y2 minus y1 squared. That is your distance formula in the orange cloud. And then, now that you have that formula, all you have to do is have your endpoints of that segment, so the points that you're trying to find the distance between, all you do is plug those points into the formula now, and you can have the distance between the 2 points. So I'm going to do that example at the bottom here. The first thing I want to do is decide what point am I going to call x1, y1, and which one am I going to call x2, y2. So I'll call this first one x1, y1, and then x2, y2. It doesn't matter which one you call which, because the distance from here to here is the same as the distance from here to here. So it doesn't matter. All right, you just have to be consistent with naming them. So distance equals the square root. Anytime you use a formula, it is a grand idea to write it down. That way you don't have to spend a ton of time before your exam trying to memorize it. So x2 minus x1 squared plus y2 minus y1 squared. Now I'm ready to plug in. Distance equals the square root. Okay, so I'm just going to give myself room to go back and write those points in. Okay, and now I'm ready to put the values in. So x2 is 1, x1 is negative 4, y2 is negative 3, and y1 is 9. Okay, so continuing, by just simplifying, I'm going to give myself some room over here. I'm going to come up over here and go in there. So d equals the square root of, well, x minus negative 4 is really x plus 4, so that's 5 squared plus negative 3 and negative 9 make negative 12 squared. Distance equals 25 plus 144, which is 169, and when you take the square root of 169, you get 13. So the distance between those 2 points is 13 units, or whatever you're measuring in. Green check or red X? Green check from Dave. Trina says green check as well. Excellent. Okay, moving along. I think I've got a few more examples with some more challenging numbers to do the distance formula with. So I'm just going to write the distance formula at the top here so I don't have to write it each time. But once again, I encourage you to write it every time you use it so that you'll know it. It's squared plus y2 minus y1 squared. All right, so I'm going to go and label each of these x1, y1, x2, y2, and I'll do the next one in turquoise. So x1, y1, x2, y2, and I'll do the last one in blue. x1, y1, x2, y2. Okay, so now I'm ready to put these points in, or the coordinates, into the formula to find the distance between those 2 points. So I have the distance equals the square root of, I'm just going to give myself the form here to plug into. And now I'm ready to put my points in. So x2 is 3, y2 is negative 2. Oh, I'm sorry. x2 is 3, x1 is negative 2. y2 is negative 4, and y1 is negative 6. So just to point out, this becomes plus, and this becomes plus as well. Distance equals the square root. Well, that's 5 squared plus negative 4 and positive 6 make 2 squared. So that's 25 plus 4 square root of 29. And that doesn't simplify any further, so you could just, so you don't FOIL. You could, but since these are all values, like literal values, you'd kind of be going around your elbow to scratch your you-know-what. Okay. If you had variables in there, you would have to FOIL it out, and then it would get really nasty looking. I don't think you'll encounter any like that. If you do, let me know, though, and I'll take it out, because that's not my point. My point is that you know how to use the formula. We pray. All right, let's move to B here and take a look at it. So the distance equals the square root of, let me give myself a little form here to fit into. Go get my other color pen. Those colors are very similar to each other. I'm going to use a completely different color. I'll use red. Okay, so x2 negative square root of 3 minus x1, which is 3 square root 3. And I'll just point out this is a negative understood 1 square root 3 there. And y2 is 4 square root 5, and y1 is understood 1 square root 5. Okay, so I'm ready to simplify. D equals, okay, so the negative 1 square root 3 and negative 3 square root 3 combine to make negative 4 square root 3s, and that's going to get squared. Plus 4 square root 5 minus 1 square root 5 leaves me with 3 square root 5, and that's going to get squared as well. Okay. So I'm going to show you, instead of just applying the exponent rule and doing it in my head, I'm literally going to show you the multiplication. It's not necessary to do it this way, but I don't want anybody confused with where things came from. So this is the same thing as negative 4 square root 3 times negative 4 square root 3 plus 3 square root 5 times 3 square root 5. So I'm just squaring those things. Okay, so with roots, you multiply outside with outside, underneath with underneath. So this first term here, negative 4 times negative 4 is positive 16. 3 times 3 is 9. So 16 square root 9 plus 3 times 3 is 9. Square root of 5 times the square root of 5 is the square root of 25. Continuing. This is 16 times, okay, I can take the square root of 9, and that's 3. So that's 16 times 3 plus 9. I can take the square root of 25 and get 5. So 9 times 5. Whenever a coefficient is in front of a root, that is multiplication that's happening there. Just to remind you of working with radicals. 16 times 3 is 48. 9 times 5 is 45. Square root of 48 plus 45, let's see, 3, carry my 1, square root of 93. I don't know if 93 has a perfect square factor in it or not. I'm grabbing my calculator. Hang on just a second. 93 divided by, nope. 93 divided by, try, nope, 36 doesn't go in. 49 doesn't go in. 64 is past halfway. I think 93 is prime. No, 93 is not prime, but it doesn't have a perfect square factor in it. It does divide by 3. Let's see what happens. 93 divided by 3 is 31, so 31 is prime. All right, so that's as far as you can go with that. Now, of course, if they want, y'all were both telling me, no, it doesn't have anything, and I just saw that. Thank y'all. Trying to make my job a little easier there. So they may ask for the decimal equivalent rounded. You just put the square root of 93 in your calculator, round to whatever place you're told to round to, put that answer in. If not, that's as simple as the square root of 93 gets. Now, if they want a simplified square root, like I said, that one is as simple as it gets, but you do have to know how to simplify square roots with some of these, because some of them can go further. All right, let's get this last one, the dreaded F word, fractions. Okay, so minus square plus this thing. Let me get my blue pen. fill in the blanks. X2, 1/3, minus X1, which is 7/3. Y2 is 6/5, minus 1/5. So they were very nice and gave us common denominators there for addition and subtraction of the fractions. If you are adding and subtracting fractions, you must have a common denominator. So 1/3 minus 7/3 is 6/3 squared, plus 6/5 minus 1/5. Oh, they were extra special nice with these. 5/5 squared. So simplifying even further, that's 2 squared plus 1 squared. Yes, you're right, Dave. 4 plus 1, square root of 5. And that's it. Y'all good with distance formula? 1.9 is not that bad of a section. Trina's typing something, so I'm going to give you a minute and take a sip of my, let's see what time it is, 3:30. So I made this coffee at 6 o'clock this morning. What happens if the denominator is different? Sorry, I'm bad with fractions. No, actually, that's why I love having students come into the classroom like this, because sometimes we do need some refreshers on stuff like that. Let me give us a clean page. And we'll do a little bit of fractional math here. So let's say we're trying to add 3/7. Let me give you your rules real quick. So with multiplication, you multiply straight across. A over B times C over D equals A times C over B times D. Division, you never divide, you multiply by the reciprocal. So if you have A over B divided by C over D, you change that to A over B times the reciprocal D over C, and then you just multiply straight across. AD over BC. Addition and subtraction, if the denominators are like. So 1/4 plus 2/4, you're going to combine the numerators over the common denominator. That gives you 3/4. So same thing, 1/4 minus 2/4, you combine the numerators over the common denominator, which in this case would give you -1/4. Okay, so what happens when you're adding and subtracting with unlike denominators? See up here. 3/7 plus 2/5. Okay, you have to get a common denominator. You first think about what is the least common denominator here. So you're trying to figure out, what do both 7 and 5 go into? Well, they both go into 35. So some way you've got to get your denominators up to 35. Well, you can't go around and multiply by numbers whenever you feel like it, because that changes things. The only number that you can multiply by that does not change something is to multiply by 1. So what you do is you have to be clever, and you multiply by 1 in the form of whatever factor you need to get to your common denominator. Because in actuality, I'm just multiplying each of these fractions by 1, because 5 divided by 5 is just 1. 7 divided by 7 is 1. But it's that clever form of 1 that's going to get that denominator to 35 so that I have a common denominator. So multiply straight across. This is 15 35ths plus 14 35ths. Combine my numerators over my common denominator, 29 35ths. And you'd reduce if you could reduce there. Excellent. All right. You're welcome, Trina. All right, the midpoint formula. Dave, I assumed you were okay since you didn't ask any questions. Were y'all both okay with? Okay, good, good. All right, so the midpoint formula. If we have a line segment and we're trying to find the middle of it, just like if you had a bunch of grades for a class and you were trying to find the middle of those grades, you would average them. You do the same thing. What you're going to do is you're going to find the average of your horizontal distance between your points. So my horizontal distance is here, which would put the average. Well, of course I'm going towards the middle's more like about right here, it looks like. And then you find your vertical average, and it takes you right to your midpoint. So here's how you do it in the formula. The formula is exactly what I just said. To average numbers, you add them up and divide by however many you have. So to get your x coordinate of your midpoint, you add your x values. There will always be 2 of them since you're trying to find the midpoint of a line segment. Line segment has 2 endpoints, so divide by 2. Do the same thing for your y's, y1 plus y2 over 2. Main thing to remember here is you're averaging. You're averaging your horizontal and your vertical positions. To arrive at the midpoint of that line segment. So to find the midpoint, take the average of the 2 x coordinates and the average of the 2 y coordinates. Here's what that looks like. So this will be x1, y1. This will be x2, y2. I'm trying to find the midpoint of that line segment with those as the endpoints. So I'm going to add and divide by 2. Add and divide by 2. And then I'm ready to put my values in. The midpoint is a point itself, so it's going to have an x-coordinate and a y-coordinate. So x1 plus x2, y1 plus y2. Oops, there we go. All right, and then you just simplify to get your midpoint. So this is 8 over 2, negative 1 over 2. The midpoint is 4, negative 1/2. Is that okay? Dave says yes. Trina says yes. Excellent. And I believe I've got some with nastier numbers to look at. And we're going to also have to deal with compound fractions here. Or, well, we might not have to. Yeah, we will deal with compound fractions. So I'll show you how to clean those up too. Trina, you should be excited about that. Learning more about fractions. All right. Okay, so I'm going to average my x values, negative 2 plus negative 6 over 2. Average my y values, negative 8 plus negative 2 over 2. So this is negative 8 over 2, negative 10 over 2. The midpoint here is negative 4, negative 5. Easy enough. Moving on to this next set. Average my x's. 8 plus negative 6 over 2. Average my y's. 3 square root 5 plus 7 square root 5 over 2 to get my x and my y coordinate. So I've got 2 over 2, and I've got 10 square root 5 over 2. So that's 1. Now, since this 10 is multiplied with the square root of 5, it's a factor. I'm actually going to break this up so you can see what's going on here. I could rewrite 10 as 2 times 5 times the square root of 5. There we go. Over 2. Now I can come back and say, because these are being multiplied, I can divide them. 2 divided by 2. So that leaves me with 1, and the y coordinate is 5 square root 5. Y'all good with that one? Dave says yes. And typing something? Trina says yes. I hate square roots. Thank you for declaring that, Dave. Most students do. They can be challenging to work with. I like them. Of course I do, though. I'm a math nerd. So. All right, averaging my y values, negative 2/5 minus negative 2/5 divided by 2. And my y values, 7/15. Oh, I'm sorry, I'm adding those, plus negative 2/5. Sorry about that, because I'm averaging them. Plus negative 4/15 over 2. All right, negative 2/5 plus negative 2/5 is negative 4/5 divided by 2. And 7/15 plus 4/15 or plus negative 4/15 is 3/15, and that's being divided by 2. You cannot leave compound fractions like that. So the good news is that compound fractions are really just fractions being divided. I put the ones under there to show you what I really have is negative 4/5 divided by 2 over 1. So I'm just going to rewrite those to make it a little easier on the eyes, and then I'll change to multiplication of the reciprocal. So, I grabbed a white pen. I was trying to write. Where is everything? So this is really the same thing as negative 4/5 divided by 2 over 1. And this is 3/15 divided by 2 over 1. So just like I said a minute ago, you never divide fractions, you multiply by the reciprocal. Negative 4/5 times the reciprocal 1/2. 3/15 times the reciprocal 1 over 2. Negative times a positive is a negative, so negative 4/10 and 3/30 multiply straight across. Now I just need to reduce that fraction. So this is negative 2/5 and 1/10. Y'all good with that? I hate fractions. So we have a lot of hate going on here today. That's okay. Sometimes it's good to just get the hate out so that it doesn't plague you and land in your shoulders. It's for attention, in the back of your neck, in your shoulders and in the back of your neck. That's where all the square roots and the fractions go. All right, the last thing we have to talk about in this section are circles. So the definition of a circle. The definition of a circle is the set of points that lie equidistant from a focus point. So if my center is my focus point, the circle is the set of points that lie equidistant from that center point. Let me clear the page out. There we go. All right. So the standard form of the equation of a circle is given as, x minus h squared plus y minus k squared equals r squared. Now I just need to describe to you what all these h's and k's and all that mean. So this x and y stay. This is the point xy that generates an xy table. So those need to stay there so that you have a place to generate points to graph. The HK is right there. HK is the center point. So the coordinates of the center point, H and K. R is exactly what you suspect that R is. R is your radius. Okay? So, let me, I thought I had an example on this page. Guess not. I could have sworn I had an example on this page. All right, I guess not. All right, so x minus h squared plus y minus k squared equals r squared will give you the equation of a circle. So if you have a circle that has a center at 0, 0 with a radius of 2, to write the standard form for the equation of that circle, I just need to fill in the blank. So x minus, oops, not y, x minus h squared plus y minus k squared equals r squared. X stays minus h. Well, in this case, my h is 0 squared plus y minus 0 squared equals 2 squared. So the equation for this particular circle is x squared plus y squared equals 4. There's the standard form that they're looking for. Is that okay? Okay. So just for the sake of example, I've got another one to work through here on the next slide, but just to give another real quick example, say you had the center of your circle at, I don't know, 1, 4, and a radius of 7. The standard form for that would be x minus 1 squared plus y minus 4 squared equals 7 squared. So x minus 1 squared plus y minus 4 squared equals 49. If you had your center, at -2, -5 with a radius of 1, that would be x minus -2 squared plus y minus -5 squared equals 1 squared. So the standard form for that one would be x plus 2 squared plus y plus 5 squared equals 1. Y'all good? Y'all get it? Trina says yes. Dave says yes. Okay, let's look at the next example. We only have one other slide after this. So here's a note about technology, about your calculators. Because circles are not functions, if you want to graph a circle on your calculator, you have to do it in 2 different pieces. That's all this part is saying. So when you get to this point of the equation, the next step is to take the square root of both sides. Well, when you take the square root, you have to take into consideration the positive and the negative. Sorry, my brother was calling. So to graph this, what you do is you go to your y equals button, and under y1 you do the positive side of it. So that's going to give this part of the circle. And then you go and for y2 you put the negative, and that gives this part of the circle. So you can graph a circle, you just have to graph it in 2 pieces. Okay. And let me see, I don't know if my little free graphing calculator will do that kind of graphing, but let me try real quick so that you can see. And we'll graph one of the circles that we just did on a previous page. So let's go here. That would be a nasty one to put into your calculator. We'll just use the one that they had as the example. All right, so let me take you out. Actually write this down so I don't forget it. The square root of 4 minus x squared. So we have the positive and the negative piece of that. Let me take you out to share my desktop. This program did this to me last time. It did not want to share my desktop last time. Sorry, I'm not going to be able to show you all that. It's not wanting to share my desktop again. I'll need to contact Collaborate another time and see what's going on with that. Okay. Write the standard form of the equation of the circle. So try that one real quick, and then post your answers in the chat window. I want to give you a chance to try one on your own. And since you're not going to be able to square it, you can just do the little caret and 2 for whatever needs to be squared. See if I can find you some circle equation writing music so that it's not institutionally quiet in here. oh, when you graphed it came out to be half of a circle. Trina, did you do each piece separately, one under y sub 1 and one under y sub 2?
Station by the lane with my hands in my pocket, tingling a wish gun.
Do you have a TI-84? Should be good. Okay, so Trina's put her answer in. Dave, are you going to submit an answer, or are you over it? You're over it. Okay, so Trina's actually correct. So when we put this in, we have x minus -2 squared plus y minus -3 squared equals 4 squared. So x plus 2 squared plus y plus 3 squared equals 16. Okay? All right, last slide. So we're actually going to kind of work backwards here and find the center and the radius, put it on the graph, and then talk about its domain and its range. So this is kind of putting everything together that we've talked about with it. All right, so the center is HK, and in this case, I have a 2 sitting in the position of H, and I would need to change the way this second one is written to y minus -4 squared, because minus is in the form there. So my H is 2 and my K is -4, and then my radius is the square root of 9, because I have r squared equals 9. Take the square root of both sides, so r is 3. My radius is 3. Now I'm ready to put this information onto a graph. My center is 2, -4. 1, 2, 3, 4, right here. I have a radius of 3. And to graph a circle, what I usually do is just mark my radius off in each direction. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Oh, I missed my mark here. All right. 1, 2, 3. And then it usually ends up looking awful, like some square-looking thing. I can draw a better circle when I'm not trying to draw it on a graph. I promise y'all I'm halfway decent at drawing circles. That wasn't that great, but I'm better than that what's on that graph there. All right, so that's how you graph a circle. You locate its center, mark off its radius, graph your circle. Now let's talk about domain and range real quick, and then we'll be done. Domain is the x-span of your function. So my function spans from -1 to +5. 1, 2, 3, 4, 5. Yes, +5. So my domain is from -1 inclusive to +5 inclusive. The range is the exact opposite. It's your y-span. So my range. Remember, you stated in number line order, so least to greatest. So I go from, let's see, 1, 2, 3, 4, 5, 6, 7, -7 to -1 inclusive. Do y'all are y'all good? Green check, red X? No response? Okay, green check, good. Last slide. So don't forget, the quiz for Unit 3 will be opening up this Thursday. Now, it stays open through Monday. However, your midterm exam opens up Monday as well. Well, it depends on when you have your scheduled appointment with the testing center on campus. But if you are an early scheduled appointment, you'll want to go ahead and get this quiz done so you can study for your final exam. Now, I had a couple people email me about the best way to study for the midterm exam. I can't take you out and share my desktop with you and take you into my math lab. Actually, let me see if it'll let me do a web tour with you and go to my math lab, because I'm going to show you the best way to study. The best way to study is to study from your old quizzes, because that's exactly where I pull your midterm questions from. So it'll be different numbers, but it'll be the same exact questions you've seen. If it'll let me log in.
Libby.
Yes.
I was just
yes.
wondering, by chance, are you going to have a lot of graphing on the midterms?
No, not too much. It would probably be more of choosing a graph as opposed to actually graphing it.
Okay.
Why do you ask?
Yeah, because
Dave?
that's where it takes a lot of time, and I was running out of time when, like, the first and second quiz
Okay.
that I took, I ran out of time, and I was just wondering if there's going to be a lot, so I'd really study up on that.
No, not too terribly much. There will be some. You'll have 2 hours, and if I'm not mistaken, the midterm is 30 questions. I think I took 10 from each quiz. I'm sorry, I keep saying I think. I wrote it last semester. It's the same one I used last semester. But I'm pretty certain, and I can go and look here in a second and let you know exactly how many questions. But if I remember correctly,
All right, appreciate that.
Yeah, not much longer than what your regular tests are. Okay, so here's how you're going to study for your midterm. You're going to go into the grade book. And I haven't attempted any quizzes, but if I had, they'd be showing up here. And next to them will be a review button. Now, this is a homework section, but the same thing happens for quizzes. And actually, Dave, would you be, like, mortified if I pulled up one of your old quizzes? If you would, that's okay. I just
go
want
ahead.
to be
Go ahead.
Okay. All right. Thank you. I appreciate that. Let me actually see. I'm trying to think of the best way to do this without showing your grades. I'm not going to be able to do this without showing grades. Okay, it's the same process as what I just did. You'll go to Gradebook. Instead of going into a homework, you'll click on a review button next to your quizzes. It will bring up one of your old quizzes. It will have the answer you gave, and if you hover, if you missed it, it'll have a little red flag in the corner of the answer space, and you can hover over it, and it will give you the correct answer. So that's how you need to go study. What I would do if I were you, I would take some blank paper, and I'd go back and open all my old quizzes with the review button, and I would write the problems down on my clean paper, and I just try to start working them without looking at anything and see what I need to study. If you can't do it without looking at notes or without looking at the answer in the quiz, then you need to study that material. If you need to study that material, what I would do is I'd first go through, maybe watch the lecture video again over it. I would perhaps go and look at my textbook. There are also multiple resources. If you go under Multimedia Library, say you're having trouble with questions from section 1.7. So Functions and Graphs is chapter 1. I'd go and find section 1.7. You can do select all, and this will bring up everything that's available for section 1.7. So you can watch an animation here on forming composite functions. So you've got multiple resources. If you want more practice problems, you can go into the study plan. And I'll show you how to do this. You're going to do View All Chapters. And I feel like I need work on Chapter 1, Section 7. And it's really writing functions as compositions that I'm having trouble with, whatever. I'd click on that, and it's going to open up all the problems that it has specifically on that concept. These don't count for or against you, so you open it up, and it's just like what you see in your homework. It's basically homework problems just for you to work. Can you bring a calculator? Yes, you can. Is it me, or does the screen say error? Oh, are y'all not? Dave, are you seeing my math lab right now?
No, it's an error. It's an error.
I'm sorry?
You are. The screen says file or directory not found.
I'm so sorry. Here I am thinking I'm just enlightening the hell out of y'all, and y'all can't see a thing. I'm seeing it. I'm getting really enlightened. Okay, so hopefully my verbal, y'all are seeing the whiteboard now with the quiz on it, right?
Yes. No,
okay.
We're seeing with the Don't Forget Unit 3.
Yes, very good. Okay, good. Well, I'm sorry you couldn't see that. You'll go into the Gradebook tab. There will be a review button. That's how you're going to review your old quizzes. I'm only going to pull, or I have only pulled your midterm questions directly from the bank of questions that made up your old quizzes, Unit 1, 2, and 3. Any other questions that y'all have for me today? Tomorrow's lecture is going to be a Unit Quiz 3 review. All right, Dave says he's okay. Trina's typing something, so I'm going to wait and see what she has to say. Nope, thank you. Well, thank y'all for showing up to the lecture today. I'll get this posted shortly after we close out here. Y'all have a wonderful day. Thank you.